Chemistry, welcome back, and today we're going to talk about components of the atom, what an atom is made up of. And an atom is really small, so sometimes it's hard to think about the parts of an atom, which are even smaller. These are only some of the parts. Physicists have discovered even more subatomic particles, that what protons and neutrons and electrons are made up of, but that is a topic for upper level physics. So the parts. We have protons. Protons have a positive charge. They are very large, and I say large and I mean subatomically large. They're bigger than electrons, but they're really not very big. They're found in the nucleus. Then we have neutrons. Neutrons have a neutral charge or no charge, a zero charge. They are also fairly large subatomically, and they are found in the nucleus with the protons. It's thought that the neutrons balance out the protons. So without neutrons there to sort of negate the power of the positive charge, the atom would sort of explode and it would never stay together. So the neutrons are important. For a long time they weren't really known what they did or what their purpose was, but now it's thought that they help hold that nucleus together to balance the subatomic particles. And then the third piece that we have are electrons. The electrons have a negative charge, and they are very small. Their mass is extremely small compared to the neutrons and the protons. And they are found outside the nucleus. They sort of orbit the nucleus. We're going to talk more about what orbit means later, but for now, think of it like a planet. Okay, so in the last video we talked about what the boxes on the periodic table represented, what the parts of that box were, and so now we're going to talk about a specific example. So we have Na. Na is sodium, and you notice that it has an 11 up here. I put it in the middle this time, but it also can go over here on the right hand side. This is its atomic number. The atomic number is the number of protons. So sodium has 11 protons. Down here we have 22.99 as its average atomic mass. When we're talking about mass, we use the decimal, but when we talk about protons, neutrons, and electrons, we need to round this number to a whole number. So in actuality, it is 23 when we're talking about protons, neutrons, and electrons, because you can't have part of a proton or part of a neutron. So we're going to round that number to 23. All other times you are to use the decimal number. The average atomic mass is the number of protons plus the number of neutrons. So knowing that the atomic mass is protons plus neutrons and the atomic number is only the protons, that helps us figure out how many protons, neutrons, and electrons there are in any atom. So, or element, sorry. So proton number is equal to the atomic number. The neutron number is the average atomic mass with the atomic number subtracted out. We'll come back to an example in a minute. And then electrons numbers are equal to the atomic number, or the number of protons. And that is a very special caveat there. The caveat is that as long as that is a neutral atom, that is an atom with no charge, then the number of negative electrons must be equal to the number of positive protons. So let's talk about sodium for a second. In sodium, we have 11 protons. We have 12 neutrons. Remember, we got that from the 23 minus 11. And then we have 11 electrons, because our proton and our electron number have to be the same. Okay, so we said that protons and electrons had to be equal. Well, what if they're not equal? What if you're in a charged atom? And that's what we're going to talk about now. A charged atom is one where the proton number does not equal the electron number. So we either have more positive charges or we have fewer negative charges. In reality, it's the difference The difference comes from the electrons. So you always have the same number of protons. You can't get rid of those because that changes your element. But you can change the number of electrons. So in the case of sodium, sodium has a +1 charge. It's a charged atom. That +1 means that we have one more positive charge, one more proton, than electrons. So we will take away one electron from our total number that we should have. So we should have 11 protons. If we have one more positive charge, and we take away one, we have 10. So we have 10 negative charges. And if you do the little math there, 11 positives minus 10 negatives gives you an overall +1 charge, which is the charge on sodium. So let's try another example. We're going to talk about chlorine. Chlorine is number 17 on the periodic table. That's its atomic number. And chlorine has an average atomic mass of 35. Okay, so number of protons is going to be 17 from our atomic number. We're going to call our 35 our mass number. Number of neutrons is 35 minus 17, and so that's 18 neutrons. Ooh. Let's tilt that board. See, you were waiting for me to dump the board on my head. Okay, and then this does not have a positive or a negative behind it, so it is a neutral atom. So in this example, chlorine's neutral. So that means that our electrons have to equal our protons. So we have 17. And so that's another example of how you find protons, neutrons, and electrons. Now, let's look at chlorine with a -1. The -1 on chlorine means that there are one more negative electrons, so we're going to add 1 to our electron number. So we have 17 protons. That can't ever change, but our electron number can. So we're going to add 1 electron to our total number of electrons to give us 18 negative charges. We take out our 17 positive charges, and we have a -1 charge overall. So that is how you find protons, neutrons, and electrons, which are all part of an atom. Thanks, chemistry.